Wind power isn't new. For decades, we've watched turbines spin on distant hills, silently converting air into electricity. But the story is changing. As the world races toward net zero, wind power is no longer just clean. It's becoming smarter, stronger, and far more sustainable than ever imagined. Forget the clunky turbines of the past. Today, the next generation of wind power is tackling everything from inefficiency to land use, from energy storage to wildlife safety. This is a revolution in motion, and it's not just about blowing in the wind. In this video, we'll explore 5 groundbreaking innovations that are reshaping wind energy as we know it, from floating farms in the sea to bladeless towers in the desert. If you think wind power is already maxed out, think again. Because the future of wind is more powerful and more sustainable than you ever imagined. Before we proceed to the video, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. 1. Floating wind turbines. Traditional wind turbines are anchored to the sea floor, limiting their reach to shallow coastal areas. But 80% of the world's offshore wind potential lies in waters too deep for fixed bottom foundations. That's where floating wind turbines come in. These massive structures are mounted on floating platforms, tethered to the seabed with mooring lines. Think of them like oil rigs, but clean. This opens up vast new ocean territory. Imagine wind farms far off the coast where winds are stronger, steadier, and less disruptive to coastal ecosystems. The technology has already arrived. In 2017, Equinor launched Hywind Scotland, the world's first floating wind farm. In 2023, the project achieved a capacity factor of over 50%, beating most fossil fuel plants in efficiency. Countries like Japan, Norway, and the US are now racing to scale up, with plans for gigawatt-scale installations. Floating turbines aren't just a neat idea. They're critical for unlocking the true potential of offshore wind. And in the next decade, we'll likely see them become the backbone of global wind infrastructure. Bladeless turbines. Let's face it, traditional turbines come with downsides. Noise, moving parts, bird strikes, and landscape disruption. Now imagine a wind generator with no blades, no gears, no rotation at all. That's the promise of bladeless wind turbines. Companies like Vortex Bladeless in Spain are developing towers that oscillate with the wind like a giant tuning fork. This motion generates electricity using electromagnetic induction without spinning blades or complex gearboxes. These units are smaller, quieter, and safer for wildlife. They can operate at lower wind speeds and be placed in urban areas, rooftops, or alongside roads. While they don't yet match traditional turbines in power output, they offer something just as valuable: versatility. In areas where full-scale turbines aren't viable, think cities, remote villages, or wildlife-sensitive zones, bladeless turbines provide an elegant, low-maintenance alternative. They won't replace conventional turbines, but they might expand where wind power can go. And for a sustainable energy mix, that matters. Advanced composite blades. Wind turbine blades are engineering marvels, light, long, and incredibly strong. But they come at a cost. Most are made from fiberglass or carbon fiber, materials that are difficult to recycle. As early turbines reach retirement age, thousands of tons of old blades are ending up in landfills. That's not sustainable. Enter the next generation of advanced composite blades. Researchers are now developing recyclable thermoplastic resins that can be melted and remolded. Companies like Siemens Gamesa have created the recyclable blade, which can be disassembled at the end of its life and reused for new products. Even better, some innovators are exploring bio-based composites, blades made from flax fibers, balsa wood, or plant-based resins. These materials lower the carbon footprint of manufacturing and enable true circularity in wind turbine production. In the future, building a turbine may no longer require extracting new raw materials. We'll reuse old ones, just as strong, just as efficient, but radically more sustainable. It's a quiet shift in material science, with massive implications for green energy. 4. AI-powered turbine optimization. Today's turbines are smart, but tomorrow's? They'll be genius-level intelligent, thanks to artificial intelligence and real-time data analytics. Modern turbines already collect terabytes of data on wind speeds, blade angles, vibrations, temperature, and performance. But raw data isn't enough. What matters is how that data is used. With artificial intelligence, turbines can now self-optimize in real time, adjusting blade pitch, yaw angles, and power output based on changing conditions. That means higher energy yields, lower mechanical stress, and predictive maintenance that prevents costly failures. Artificial intelligence also plays a role at the grid level. By forecasting wind patterns and demand, algorithms can better integrate wind power with other renewables, balancing the load and minimizing waste. In Denmark, artificial intelligence has helped increase wind integration into the national grid by over 30%. In the US, companies like Uptake and Spark Cognition are optimizing fleet-wide performance for wind farms. Artificial intelligence won't generate energy on its own, but it'll help us use wind smarter, longer, and with less waste. In a world where efficiency is everything, intelligence is power. Built-in energy storage. Wind is powerful, but it's not always reliable. The wind blows when it wants, not always when we need it. That's where built-in energy storage is changing the game. Instead of feeding power directly into the grid, next-gen wind farms now integrate batteries, flywheels, or even hydrogen systems to store excess electricity for later use. Take Redflow in Australia, or Form Energy in the US. Both pioneering long-duration battery storage that pairs perfectly with renewable energy. Even more futuristic? Some turbine makers are developing towers that store energy inside themselves. One concept by Energy Vault uses excess wind power to lift massive concrete blocks. When energy is needed, gravity brings the blocks down, powering generators, no chemicals, no batteries, just physics. Other systems convert wind power into hydrogen via electrolysis, an energy carrier that can be stored indefinitely and used for transport or heating. By embedding storage directly into the wind system, we remove wind's biggest weakness, intermittency. And that's not just an upgrade, it's a complete transformation of how wind energy works. Wind energy is already one of the cheapest and cleanest sources of electricity, but its next chapter will be even more extraordinary. Floating farms that harvest untapped offshore power, bladeless generators that bring wind to the city, smart turbines that think on their own, materials that recycle themselves, and storage systems that hold the breeze until we're ready to use it. This isn't just about producing more energy, it's about doing it better. Cleaner, smarter, more sustainably. If the 20th century belonged to oil and gas, the 21st belongs to the wind. And as the planet shifts toward renewables, wind power isn't just catching up, it's taking the lead. The future isn't just blowing in the wind, it's being built with it. If you enjoyed what you saw, don't forget to hit the like button and ring the notification bell so you never miss our upcoming videos. Your support means a lot to us. Take care until the next one, and feel free to drop a comment sharing your thoughts. See you soon.